Okay guys, so for our project we chose to do a little explanation on the few problems in the beginning of the term where we had to find or calculate the probability that a coin, we're going to use a coin with a 1 centimeter radius, and we're going to calculate the percentage chance that it's going to land within the shapes of different tessellated regions. And so we're just going to start with some straight lines. Sheila, want to take it away?
Right. So for this one, the cone we'll be using will have a 1 centimeter radius. It's going to be thrown onto an arbitrary plane, which is going to have a length of 4 centimeters. Now, if the center of the coin is less than its radius away, which is less than 1 away from the edge, it'll be touching the line, which therefore means that it won't be on the shape. So therefore, the maximum length that it can be, the minimum length it can be from the edge would be 1 centimeter. So therefore, the coin center can be in this length area of 2 centimeters. So from there we can see that since the height does not matter where it is placed, then the coin can land in 2 centimeters area out of the entire 4 centimeter area, thus giving us a 50% chance of landing inside the shape. Now if we looked at this without knowing the length and without knowing the radius, we simply use the equation L, which is the length between the two lines, minus 2r, which is r being the radius of this coin, over L. Now, if you just plug this back in, it would be 4 minus 2 times 1, so 4 minus 2 is 2, over 4 would give us 1/2. Times 100 would be 50, and that would be the percentage. And that will work for anyone.
Okay guys, now we're going to move on to tessellated region with 5 by 5 squares.
Thank you, Luke. Now, looking at this one square, we see that its dimensions are 5 by 5, and once again we have the same circle, coin, with a radius of 1. Now we know, as before, that if the center is less than 1 centimeter away from the shape, then it cannot be. So we made an inside square, of which the circle can be anywhere inside this, and it will land inside the shape. And since we know that the minimum length can be away from the outside of the square is 1 centimeter, and we know that this is 1 centimeter, and then this is also 1 centimeter. The inside square area of which the shape of the coin can land in is 3 centimeters. Now we're going to simply take the areas of both. So since it's a cube, it'll be 3 times 3 equals 9, the area of that smaller square, over 5 times 5 equals 25, the area of the larger square. And if we simply do that, 9 over 25 gives us 36%, so 36% chance that the coin will fall inside, so that's a slightly smaller possibility. Now if we look at this square right here, it's the same thing except the length of the radius of the coin is r, and the length of the cube is simply L. Now working from that same thing, we'll just simply get L minus 2r, because that's r and r, that's 2r, so that's L minus 2r squared, since it's a cube, over L squared times 100 will be the percentage we have for the probability. So if we plug that in, that'd be 5 minus 2 times 1, so that's 3 squared over 5 squared. And that'll give us 9 over 25 times 100, and that'll give you 36%.
Okay guys, so now we're going to move on to a tessellated region with equilateral triangles, length 10 centimeters. Just to give you a visual, this is what the tessellated region would look like. But since the probability of the coin landing in each one of them is going to be the same, we're just going to focus on one of them. It's pretty much the same idea as with the lined paper and with the cubes. We're going to track the center of the coin and find the area that the center of the coin can land. Obviously that's going to be a similar triangle to the larger one, but it's going to be scaled down by the 1 centimeter all around. And so to find the areas of both this region where the center is landing and to this outside triangle, we have to find the length of this smaller triangle, and to do that we're going to focus in on one of these corners. So first of all, you know that this length is 60 degrees because it's an equilateral triangle, just as it is in this triangle, because they're similar. And because you know that this is a kite, because these lengths are both 1 centimeter and these lengths are both the same, then you know that this diagonal is going to bisect this 60-degree angle, making this angle measurement 30 degrees. And then we can do 1 divided by tan 30 to get this adjacent side, which is root 3. And now we know that this over here in the other corner is also going to be root 3 because it's just another kite. And so we know that the length of this is going to be 10 minus 2 root 3. And then if we're going to now find the areas, we're going to use 1/2 base times height. And so 2 root 3, which is equal to 6.536, divided by 2 times sine of this 60-degree angle times the hypotenuse, which is 6.536, because this is an equilateral triangle. It's going to get us this height. Then we put that over 5, which is 1/2 of this base of the larger triangle, times sine of this 60-degree angle times the hypotenuse, which is 10. That's going to get us this larger height. And that's going to get you the percentage 43%. And that's the possibility that the center will land within this triangle, and therefore that the whole coin will be within the larger triangle. And if you were going to write an expression for this, it would just be L minus 2 R over tan 30 divided by 2. That's going to get you 1/2 the base of the smaller triangle times the sine 60 L minus 2 R divided by tan 30, and then all over the area of the larger triangle, which is L over 2 times sine 60 times L.
Alright, for review, make sure the center of the coin is safely inside the shape so that the outside points of the circle don't touch the shape. Now, in any of these cases, just keep that one rule in mind, and I'm sure you'll be fine. If you want any extra work over break for practice on these problems, just make sure to do something like page 5, number 6, page 7, number 9, or page 9, number 11. Those contain tessellated shapes that you can use to test out and hone your skills in finding the probability that these coins will follow the shapes. Thank you, and have a nice day.
Hey guys, and thanks to my brother Sam for doing the audio.